So as you can see in this video, I'm going to design an XNOR Gate. Then I'm going to simulate it, then the power curve and also the average power. So at first I'm going to open a library. Let's name it XNOR. Then you have to select the attach to an existing technology library. Okay. Now GPTK 090. Okay. Now you have to open a cell view. Let's name it XNOR 1. XNOR 1. And you have to select the library that I have opened earlier. This is the XNOR. So yes, that's okay. This is our cadence. So you have to press I from the keyboard for the instance. Now browse GPTK090. For this, I'm going to bring the NMOS, then symbol. This is our 1 NMOS, 2 NMOS, 3 NMOS, 4 NMOS. And same as you have to press again the instance I, then you have to bring the PMOS. This is the PMOS symbol. We need 4 of them. 1, 2, 3, 4. Same as you have to press again I from the keyboard. Now you're gonna select the analog lib. I mean analog library. Then you're gonna press ground, G and D, ground. We are gonna need 1, 2, 3, 4 ground. We're gonna need 4 ground. Instance again. Now VDC symbol or 1 VDC and VPulse, VPulse, VPulse symbol. Yes, you're gonna need 2 VPulse. Now I'm making the screen bigger. Now you're gonna press the W from keyboard because it will give you the wire. Now connect them. Just make the connection as I'm doing right now. This is for our pull-up PMOS. This is the pull-up network. And for NMOS, this is our pull-down network. I think I've mistaken something. We should mirror it. For mirroring, you have to select the in here, flip horizontal. This will make your connection easier. Now press the W again from the keyboard. Now make the connection between them. You have to connect it to the ground. Also for this one, just short them. This is our pull down network, and this is for our pull up network. Let's select it and delete. Okay, you have to connect it in upper side. Yes, this is our connection, and you have to take the output between the NMOS and PMOS. This is our output line. So this is our output. Escape. This is our main connection. And for the input, you have to press P from the keyboard. I've pressed it. P. Now for input, you're gonna write input, and you have to select it from here. This is our input. So we are going to add A, B, sorry, again input. This is our two inputs. And now we are gonna need two inverters. For this, we have to design two inverters. For instance, I'll click I from the keyboard. Then same as before, I'm going to select the NMOS from the GPTK90. Here is the NMOS 1 volt. This is our one NMOS, and exactly same. I'm going to bring another PMOS. This is our PMOS. Yes. Now I'm gonna take the ground from here. This is our ground. And VDC, we are gonna need VDC. Okay. Zoom it and connect them. Why we are using the inverter? Because in order to design the XNOR gate, you will have to need one A inverted and one B inverted. So in order to invert them, you are gonna need inverter. So here is the connection I'm going to do. This is the output. Okay, this is the input set of the inverter, and this is the output set of the inverter. You don't have to design again, you just can copy it. I've selected it. Right click of your mouse, then copy, click one. Here is our another inverter. Okay, now why I have designed two inverters, shortly you will gonna find it. Okay, now press the W for the wire and connect it in this input A, and this is the yes. And for B, I'm going to connect it in here. Okay, again I'm going to press W for the wire. This is our another input. This is our another input. Okay, in this PMOS, the lower segment of this PMOS, there will be connected A bar and B bar, and in here there will be A bar and B bar. That means there will be an A bar and there will be a B bar. So now we have to take two inputs. For input, you are going to press the P from the keyboard and going to write input. This is our one input, suppose, and again I'm going to press P in the keyboard, and I'm going to press again for input. Okay, this is our two inputs, and for the output we have to press P and write OUT. Okay, this output, but you have to select it from in here. This is our output. Now let's place them. At first I'm going to mirror them, one input from this. Okay, let's place the output at first. This is for our output. Okay, and for the input, this is our I didn't mirror it. Okay, let's put it in here and let's name it B, input B. Now as we can see, this is the inverter, and if it takes the B, that means it will give us inverted version of input B. That means this is our BI. Let's name it BI. That means B inverted, BI. As you can see, this is named BI. Again, I'm doing the same for the another inverter, which will be input A. Yes, it is successfully connected. And double click it and name it A. And the inverted version of A will be AI. That means AI. This is our AI. Now we have so many grounds we didn't use it. Let's put the grounds. One ground goes in here. Yes. And we have to put the DC source. And along with the ground for the DC source. This is our ground. This is our DC source. Let's connect it. To connect it, you have to write the W. You have to press the W in your keyboard. That will give you the wire. And let's connect them. Extra wire do not allowed. Okay. So these are V pulse. Okay, V pulse. For V pulse, you have to take it to the input B, and another V pulse goes to the input A. That means in here. Now the ground goes to the V pulse. Exactly same. To connect them, you have to press the W from the keyboard. Wire. Wire. Yes. Oh, I have to bring another ground. For this, I'm going to press I from the keyboard, browse, analog lib, and you're gonna write G and D, ground. This is our ground. Okay. So we have successfully connected all the necessary things, I believe. Okay. Now we have to name the inputs. For this, you are going to press W. There is our one input. Again W. Here is our another input. W. Okay. Now you have to just name the inputs. For this, I'm going to press in here and write AI. That means inverted version of A. B, BI. That means inverted version of B. So the first name I have named A. So this is our A input, A. The second one is AI. That means This wire is AI. Now BI, sorry, now B. This is our B input, and this is the BI input. Now for the pull down network, I have mistakenly there. Here is another connection W. Now in the pull down network, you have to name exactly same. This AI actually connected to the, this AI is connected to the in here, and this is the BI which is connected to this, and this is our P. So it goes directly in here. Oh no, I have already connected it. Sorry. So I think I've connected all the necessary wires. Now the interesting part is this wire is connected to this. For the inverter, you will have to need two DC sources also. For this, I've already said instance for keyboard I. Now I'm going to bring some DC sources. Okay, I need grounds. Here is one ground, and here is two. Again, I for the instance, DC. Okay, so VDC. This is our one VDC. This is our second VDC. Now just connect the ground below the VDC and press the W wire from the keyboard. Okay, connected it. Just connect like this. Again, you can do same for this inverter too. Now connect the ground. Yes, I think I've successfully constructed the whole circuit. Now I'm going to go the simulation part. Yes, at first I have to select this V source, VDC source. I'm going to give it a value. So VDC voltage, let's put it 2 volt. Okay. Same to same, I'm going to give it 2 volt. Okay. And this one I have already selected 2 volt. V pulse. For V pulse, now for V pulse, on V pulse, तो should select code C. Acha, now for V pulse, you are going to select the right click, properties, and voltage 2. I have selected 1 volt. Period I have given 40 nanovolt. Acha, ওটা লাগবে না. Okay, that's pretty much all. Now this is the main part. Go to the launch, ADEL. Go to the setup section, models libraries, double click it, and you are going to select the MOS SCS open, double click the NN and select the TTS1V. Okay, now for you have to go to the outputs to be plotted. That means which portion you want to plot. Like you have to select it from the schematic. That means I have to select the input A and I have to select the input B because I'm going to plot them, input A and input B. Then I'm going to plot the output. That means I have to select the output. You can see in here I've selected the input A, input B and output. Now I have to go back to the same window again. Outputs, analyze, setup. You have to click the setup. Sorry, you don't have to click setup. You have to click the analyze, choose. Now stopping time, I'm going to give it 120 nanosecond, moderate. Okay, I think I have to check and save this circuit one time. So okay, now go to the simulation, netlist and run. So yes, Oh wait, I have to uncheck this one because I don't need this, because I just want to see the input, two inputs A and B, and the output. Run again. Let's split the waveforms. Now, as you can see, this is our A input and B input, and this is the output. Now, if we see the truth table of the XNOR gate, we know when the both inputs are high, that means 1, 1, the output should be 1, but this is 0. That means we actually constructed the XOR gate. If you see this one, when the A is 1, B is 0, A is 1, B is 0, the output should be 0, because the truth table of the XNOR says so. But we can see the output is 1. That means this is XOR gate. So we have to add another inverter to the main circuit, where we have to we can just select it, copy. So after connecting another inverter, I have made a little bit change. As you can see, in this inverter there is a input B, and in this inverter there is input A. So you have connected two sources. This is one source, this is for one source. But this inverter doesn't need any source because it is not an input. It is just taking the output of this whole circuit and inverting it. So this is actually the input, and it is connected to, if I touch in the this wire, you can see the main wire lighting up. See, this is lighting up. That means they are both connected. So it doesn't need any source. So I've deleted this source. My video suddenly stopped, so I couldn't show you. So this it doesn't need any source, and this is the output, our main output. And in this voltage source, you are going to set 2 volt. I've set 2 volt. Okay. Now let's go to the simulation profile. Here you can see this is our new output, which is in here, and this is our input A, this is our input B, this is our main output. Now let's simulate it. Simulation, netlist and run. This is my A input, this is my B input, and this is the output. Netlist and run. Let's wait. Let's split the input and output. Okay, as you can see, here is our first input A, and this is the input B, and this is our output. This output is really precise. I think it's a good output. Okay, let's relate it with the truth table. According to the truth table of XNOR gate, we know when the both input is low, that means A is 0 and B is 0, the output will be 1. So in here, A is 0, that means low, B is 0, that means low, the output is 1. In here, the A input is 1, B input is 1, the output is 1. But when A is 1, B is 0, the output is 0. So yes, that's pretty much all. This is our output. And in the next video, I'm going to show you the calculation of average power and the power curve. Thank you.